equations with x and y. And you remember that solving means to find all values of x and y to make the equation true. So let's find some solutions to this equation, values of x and y that make it true. Well, let's see. Well, if x equals 1 and y equals 3, 1 plus 3 is 4. Maybe do 5 and negative 1 to be interesting. And zeros are always easy. So let's use x equals 0, y equals 4. Okay, and you guys remember from last lesson like this, we only need 3 points to determine where a straight line is. And actually it's only 2, but 3 will help you catch it if you make a mistake. And I also recommend that you don't have your x's and y's in a pattern, because if they're in a pattern, they're going to make a straight line whether it's correct or not. So it's best that you go back to the equation every time to make sure it's true. Okay, so let's plot those points. Got 1, 3, 5, negative 1, and 0, 4. Okay, and we can see that those points are in a straight line. Remember, we're going to represent all of the little decimal solutions in between the points and all the other solutions by drawing this straight line in. We're going to draw our straight line all the way across the grid and then put arrows on the ends to represent that it keeps going forever in both directions. So there we go. All of the points on that straight line will make this equation x plus y equals 4 true. Okay, question 5. Again, we just need a table of values with 3 points in it. X minus y equals 5, so let's see, 6 minus 1 would equal 5. 0 minus negative 5 would equal 5. And what else do we have here? Let's go 5 minus 0 would also equal 5. And notice these aren't in a pattern at all. So I've got the point 6, 1 is there. 0, negative 5 is there. And 5, 0 is there. And again, our points are in a straight line, so we can fill in the rest of the infinite solutions by drawing this straight line and putting arrows on the end. And again, all of the points on that line will make the equation x minus y equals 5 true. So they're all solutions to that equation. Okay, and now for some reason it jumps from 5 to 14. Don't ask me why. I made the worksheet, so I made a mistake is why. Okay. This one's a little bit more complicated. 2x minus 3y equals 6. But again, we're still doing the same thing. We're trying to find x, y combinations that make this true. 0 can really be your friend here. So if x equals 0, that would just be 0. It means that negative 3y would have to equal 6. So then y would have to equal negative 2. So we'd have the point 0, negative 2. And if y was 0, then x would have to be 3. So we'd have the point 3, 0. And now we just need one more point. Yeah, we could do 12 minus 6. So to get 12 minus 6, x would have to be 6 and y would have to be 2. Ooh, but that's a pattern. Okay. Why don't we go negative 6 plus 12 then? So x would have to be negative 3. And y would have to be negative 4. That would give us 6 plus 12. Okay. So we've got 0, negative 2, 3, 0, and negative 3, negative 4 is there. Okay, and again, our points are in a straight line. There we go. And those are all the rest of the infinite points that make that equation true. Okay, here we go, 15. Y equals 3, that's all they're giving us. Okay, and we need all values of x and y to make this true. Notice we need all values of x and y because we want to plot it on this grid here. Okay, well, the one that students usually come up with first is if x equals 0 and y equals 3. And yeah, that works, because if y equals 3, I mean, we can even do a check on it, right? We'd have y equals 3, so we'd substitute in a 3 for y, and we get 3 equals 3, which is obviously true. Okay. So, it's kind of a question, but it's actually really, really easy. We just need any x-y combination where y equals 3, because the equation is y equals 3. So I could use 10(3), because there's no x in this equation, so if y equals 3, it's true. So 10(3) works. I could also do 2(3). Okay, so let's put those points on the graph and see what this is going to look like. We've got 0(3), got 10(3), and we've got 2(3). Okay, which means we're going to have a horizontal line here. And actually, you can probably see that every point on this line, y equals 3. Which means that it's going to make that equation true. So every point on this line will be a solution to y equals 3. Okay, we've got one more like this. This time we've got x equals -5. And we just need 3 points where x equals -5. So we could do -5, I don't know, 0. We could do -5, -2. And we could do -5, 7. And notice these y's I just chose for no reason. Okay, so there's -5, 0, -5, -2, and -5, 7. And in this case, we're going to have a vertical line, and everywhere on that line, x is going to equal -5, which makes sense because it needs to be the solution to the equation, x equals -5. So, oh, notice my line's a little bit off there. Obviously, it should be exactly straight, not slightly crooked. I apologize for that. Okay, yeah, so, you know, these last two, they may feel a bit complicated, but they're actually really easy. All of the solutions to x equals -5 must have x equal to -5, which will give us this vertical line. Okay, you should be ready to do your assignment now. Have fun.